Hello children, in the previous lecture I discussed about forces, and in today's lecture I will discuss about Galileo's observations and Newton's laws of motion. So let us start with Galileo's observation. Galileo was the first one who analyzed states of a body, state of rest or a state of motion. So let us see what type of activities Galileo did to understand the motion. You can also perform the same experiment, same activity to understand it well. You have an inclined plane and you have another inclined plane. Galileo also took the same thing. After then, he dropped a ball from this position, and whenever he dropped the ball from this position, he observed that the ball reached this point A, and after then it traveled along this inclined. Means the ball reached this point A under the effect of gravity. So its velocity was going to increase. At A, it acquired maximum velocity. And after then it starts moving up the incline. And whenever the ball started moving up the incline, the acceleration due to gravity started acting downwards, as a result of which its velocity started decreasing, and its velocity became zero when the ball reached at point B. You can perform the same experiment. If you will allow to fall a body from this point along the incline, it will go up to this point B. You just observe that the angle of inclination for this surface is equal to angle of inclination for this surface. It is also observed that, you can also observe that this distance is d, means distances travelled in both the cases, down the incline and up the incline, are equal. Now you just decrease the angle of inclination. Just decrease the angle of inclination. You make it theta 1, such that theta 1 is less than theta. What will happen? If you will drop a ball, the ball will reach this position, B1. The height of the ball attained is same as that its initial height from the reference level. If the angle of inclination decreases further, reduced further, suppose theta 2, the ball reached the point B2. The height is still same, but you can easily understand that the distances travelled in this case and this case are different. Suppose this is the distance travelled in this case d1 and distance travelled in this case d2. You can obviously observe that theta 1 is less than theta and theta 2 is less than theta 1, while d2 is greater than d1 and d1 is greater than d. Means if angle of inclination is reduced, distance travelled by the ball increases. What will happen? You just think, what will happen if the angle of inclination will become 0? That is, this surface will be horizontal. In that situation, the ball will never attain the height h. So it will continue to be moving. You can perform this activity at your home also. And same was performed by Galileo. And on the basis of this observation, Galileo concluded that if a body is set into motion, it continues to be in motion. And if it is at rest, it continues to be at rest. Now see what type of motion is that. Whenever the ball will be dropped from here, the ball will travel along the incline under the effect of gravity, means acceleration due to gravity is acting on the ball, so its velocity is going to increase, and at A the velocity becomes maximum, and after then it starts moving along the horizontal direction. If this inclined plane will be horizontal, then there will be no acceleration along the direction of motion, as a result of which the velocity will be uniform, means the ball will continue to be in uniform motion. Let us take another example. If a ball is kept on the table, you can easily observe that the ball never starts moving itself, but the ball will start moving if you will apply some external force. So these were the observations made by Galileo. You can also observe all these facts by performing an activity at your home. Okay, so what are the main observations? First thing is that every body at rest continues to be at rest. Second, a body set into uniform motion continues to be in uniform motion forever. So these were the observations of Galileo, and we can conclude these two facts. After that, Newton came, and Newton repeated the same experiment, same activity. He worked with this type of situation, and he proposed 3 different laws, and they are called Newton's laws of motion. So Newton's laws of motion are based on Galileo's observations. You can also say that Newton's laws of motion are somehow more explanatory in comparison to Galileo's laws of motion or Galileo's observations. So let us discuss with Newton's laws of motion now. Newton's laws of motion. Newton proposed 3 different laws of motion. First law of motion is somehow Galileo's laws of motion. First law of motion is somehow Galileo's law of motion. You see, what is this? In first law of motion, Newton told that every body continues its present state of rest or of uniform motion unless an external force is applied on the body to change its state. Have you got? First law of motion has 2 parts. First part is that every body continues its present state of rest or of uniform motion. This shows a continuous behavior. This shows a continuous behavior of a body. Means a body continues its present state. And second part, there is an external force which can change the present state. So Newton's laws of motion gives us idea about 2 different parts for its first law. First, continuity, means behavior of a body, state of a body, and second, force. So behavior of the body, due to which it continues its present state of rest or of uniform motion, is called inertia. Means first part of first law of motion defines inertia. Hence, first law of motion is also called law of inertia. First law of motion is also called law of inertia. And second part of first law of motion defines a physical quantity which can change the state of a body, and that quantity is called force. Have you understand? You can write first law of motion now. Every body continues its present state of rest or of uniform motion unless an external force is applied on the body to change its state. This is the law of motion. First part of this law defines inertia, and second part defines force. Hence, first law of motion is also called law of inertia. This is all. In the next lecture, I will describe inertia, I will describe force, and then we'll move to the second law of motion. Thank you.